Hello students, today we are going to discuss, we will start a new chapter, that is redox reaction. We know on the basis of change in the formula of the compounds, that addition of oxygen, removal of oxygen, addition of hydrogen, removal of hydrogen, addition of electronegative element, removal of electronegative element, addition of electron, gain of electron. So different types of reaction takes place in chemical changes, that some reaction involves in these categories, that maybe loss or gain of some electron, hydrogen, oxygen, electronic element takes place. On that basis, chemical reactions also classified in different types. But basing on some specific change, your whole reactions on the basis of both, that where both change takes place, we can say addition of electron and gain of electron. For this, that is the similar types of changes takes place in the different reaction. So a redox reaction, here in this chapter we will discuss that oxidation and reduction reactions. What do you mean by oxidation reaction? What do you mean by reduction reaction? And if both takes place, what is called? That is called redox reaction. And how can you know the charge of the particular element in the compound or in the radicals? Then whether the oxidation number is increasing or decreasing due to oxidation, increase and decrease in oxidation number, what change takes place? So many factors we'll discuss. So particularly redox reaction are two types. One is the whole redox reaction. There are two types. One is oxidation reaction, and another one reduction reaction. Oxidation reaction and reduction reaction, there's mainly two types. This redox reaction, when both takes place, this redox reaction generally when both reaction takes place, it is called redox reaction. Where both oxidation and reduction reaction takes place, it is called redox reaction. Oxidation reaction indicates addition of oxygen. Addition of oxygen is called also oxidation. And for example, your carbon plus oxygen when heated produce carbon dioxide. You see the change. Here carbon with carbon, if you see the left side here carbon, free carbon, but on the right side it is combined with oxygen. That means oxygen is added to carbon. Then we can say carbon undergo oxidation because oxygen is added to the carbon. Carbon is undergo oxidation. Here, this change if you see, so it is an oxidation reaction. Carbon changes to carbon dioxide is called oxidation. Then, removal of hydrogen. removal of hydrogen is also called what? Oxidation. If hydrogen is removed, then it is called also what? Oxidation. For example, we can say, suppose you see H2S plus bromine. Here, product is HBr plus S. Just you see these things. Just we check this change. H2S to S. Here, left side hydrogen added with sulfur, but in the right side no hydrogen. That means loss of hydrogen, removal of hydrogen. So it is called oxidation. Because here H2S undergo oxidation to sulfur because loss of hydrogen takes place. Similarly here carbon undergo oxidation to carbon dioxide due to addition of oxygen. So like this. Then 3 we can take loss of electron. If you see the transfer of electron, if electron is lost, that is also called oxidation. For example, here we can say that sodium convert to sodium plus. Here this change is a oxidation change because sodium is neutral atom convert to Na plus due to loss of electron. So sodium here convert to sodium plus means sodium is oxidized, that means sodium undergo oxidation to Na plus. So this is also called oxidation. And another is oxidation is addition of electronegative element. Addition of electronegative element is also undergo oxidation. For example, same example, write bromine plus H2S changes to HBr plus S. Just you see, bromine is added to H2S. Bromine is added to H2S. As bromine is an electronegative element, is directly added to H2S. So H2S undergo oxidation. This is the meaning. But we can see the change already discussed. H2S to S. In this case, it is oxidation. Loss of hydrogen. That is the meaning is same. Only way of expression is different. Here what happens? H2S loss of hydrogen, that is oxidation. But here addition of electronegative element. Here electronegative element is added means that's why H2S undergo oxidation. That is definition. Addition of electronegative element means the substance will be undergo oxidation. So already oxidation takes place, loss of hydrogen is satisfying the definition. So in this way, 4 examples, that addition of oxygen, removal of hydrogen, loss of electron and addition of electronegative element is involved, that oxidation reaction. Similarly, reduction we can say that addition of hydrogen. Addition of hydrogen is also called reduction. For example, you take suppose sodium plus hydrogen plus nitrogen convert to ammonia. Here hydrogen is added to nitrogen, so it undergo reductions. Nitrogen is undergoing reductions. Here nitrogen is reduced. So addition of hydrogen is called reduction. Hydrogen plus chlorine, that is HCl. That is also here chlorine is reduced. Fluorine undergo reduction, nitrogen undergo reduction because addition of hydrogen. Specific definition. Then second, that removal of oxygen. Removal of oxygen is also removal of oxygen is also an oxidation, that is reduction. Removal of oxygen. For example, zinc oxide plus carbon on heating produce zinc plus carbon monoxide. You see here zinc oxide containing oxygen, but in the right side it has no oxygen, means loss of oxygen. That's why zinc oxide is reduced. It undergo reduction because loss of oxygen. Third definition is that gain of electron. Gain of electron is also called reduction. For example, chlorine plus E changes to Cl minus. Sodium plus E changes to sodium. Here, if you see here addition of electron, gain of electron, both we can tell that here gain of electron by sodium Na plus, here gain of electron by chlorine. Both cases is called reductions. Then fourth one, that loss of electronegative element. Loss of electronegative element is also called that reduction. For example, HCl plus zinc. Here what happens? Here HCl convert to zinc. Here product is zinc chloride plus hydrogen. Just you see HCl and zinc. Here HCl contain electronegative atom, that is chlorine. When electronegative atom losing chlorine, that is here HCl is losing chlorine. When chlorine is lost from HCl, a loss of electronegative element results, that is reduction. So HCl is convert to H2, HCl is convert to H2. So loss of electronegative element. That means here you can say it is also one case of reduction. It is a one case of reduction. Loss of electronegative element. That's why oxidation reduction reaction can be defined in different ways on the basis of different, but the meaning is same, but the mode of expression are different. But both can be taken together. Both involve loss of electron or gain of electron. But it may be addition of oxygen, may be removal of oxygen, addition of hydrogen, removal of hydrogen, like this. But both cases, if you take, it is the important last point is that gain or loss of electron. Gain of electron is reduction and loss of electron is oxidation. So on the basis of this, there are two types of reaction, that is oxidation and reduction reaction. Combinedly both is called redox reaction. Then very important thing is that how can you know charge of the atom, that is called oxidation number. Oxidation number. Oxidation number means that is charge charge of atom in the molecule is called its oxidation number. What is the charge given on the atom in the molecule is called its oxidation number. Oxidation number means it may be positive, or negative. It may be positive or it may be negative. Oxidation number may be positive or may be negative. But how can you calculate oxidation number? Oxidation number can be calculated based on the rules of the oxidation number calculation. Rules of calculation of oxidation number. The rules is like this: total oxidation number of all elements. Total oxidation number of all elements in the compound is 0. Total oxidation number will be 0. Total oxidation number of elements in a radical is equal to its charge. For radical, its oxidation number will be its charge. Total oxidation number elements in a radical is equal to its charge. Oxidation number of hydrogen is +1 except hydrides, that is -1. In case of all cases, the hydrogen oxidation number is +1, but in case of hydrides, that is -1. Oxidation number of oxygen is -2, but in peroxide it is -1. Oxidation number of oxygen is -2, but in peroxide it is -1. Oxidation number of electronegative element is negative, and for electropositive element is positive. This is very important. For example, for metal case it will be positive sign, and for non-metal case it is negative sign. So this is some important rules that oxidation number calculation. So let us calculate some oxidation number. For example, oxidation number of sulfur in sulfuric acid we will calculate. Suppose we will calculate for sulfur. Charge of sulfur in sulfuric acid, that is oxidation number. For hydrogen, it is for hydrogen always +1, so it is 2 hydrogen is 2 into 1 plus 1 sulfur is X, and here oxygen, how many oxygen here? That is 4 oxygen, each oxygen carry -2, that is -8. As it is a neutral compound, so it is 0. Already we have the, now we are using this rule, total oxidation number is 0, so implies X is equal to +6. When you calculate oxidation number, you will write in a box. Oxidation number means you have to show either plus or minus. Then oxidation number of nitrogen in nitric acid, like this, 1 for hydrogen, and for nitrogen is X, and for 3-oxygen is minus 6 is equal to 0, implies X is equal to plus 5. So this is the oxidation number of what? Nitrogen. For example, potassium cyanide, potassium ferrocyanide, CN46. How to calculate the oxidation number of, that is iron? For potassium as electropositive element, potassium valence 1, so it is 4. Plus here 1 iron, that is X, plus here cyanide, you have to see the charge. Cyanide is carry always minus charge, that's why 6 cyanide is minus 6 is equal to 0, implies what is the value of X? X value will be plus 2. So the oxidation number of iron in potassium ferrocyanide is plus 2. For example, what is the oxidation number of phosphorus in phosphate? Phosphate radical intake. What is the oxidation number of phosphorus in phosphate? For example, here phosphorus is X, and here 4 oxygen is minus 8, and is equal to minus 3 because it is radical. Already you have written total oxidation number elements in radical is equal to charge. So as the charge of phosphate is minus 3, so X minus 8 is equal to minus 3 implies X is equal to plus 5. So this is some tricks to calculate the oxidation number of elements. But now we discuss some difficulty level. How the oxidation number of elements is calculated from the structure. Because from the formula, if you calculate using the formula, then it will be wrong. But we have to see the actual arrangement of elements in the structure. Then we can know the difference in the oxidation number. Okay, you write this one, then we will. Let us take that H2SO5. This is called peroxomonosulfuric acid. If you draw the structure, then the structure is like this. This is your this is the actual structure of peroxomonosulfuric acid. This structure shows that these 3 oxygen in oxide form and this 2 oxygen in peroxide form. OO, that is peroxide. This linkage is called peroxide. This is called peroxide. This is called peroxide linkage. As in peroxide already we have discussed, in case of peroxide each oxygen carry minus 1. That's why we have to put like this. So this 3 oxygen for hydrogen will be 1 and for 3 oxygen will be minus 6 and sulfur will be X. Then this 2 oxygen will be minus 2 and last hydrogen will be 1 equal to 0. Again I am repeating. These 2 oxygen in peroxide form. Peroxide means each oxygen carry minus 1 as per the rule. As per the rule this one. So this 2 oxygen will be minus 2 and sulfur will be X. 3 oxygen will be minus 6. 1 hydrogen 1. Last hydrogen 1. So is equal to 0, then value of X is equal to how much? So minus 6, that is here minus 2 minus 8 and here 2, that is minus 6, X value will be plus 6. So this is the actual calculation. If you, without structure if you do, what is the oxidation number without calculation? So sulfur will be, that is how many oxygen? Here in 5 oxygen, that is minus 10, sulfur X, 2 hydrogen, plus 2 is equal to 0, X is equal to plus 8. So this is wrong. This is wrong because sulfur oxidation number cannot be 8. The maximum oxidation state of sulfur is plus 6 because you know it has how many valence electrons? 6 valence electron means maximum oxidation number will be 6. cannot be 8. So this is wrong. We can also, in this way, you can also know whether your calculation is correct or not. You have to also verify it. So this is one method that you have to draw the structure. Similarly, H2O8, H2S2O8, this is called Marshall acid, or that we can say it is also called that is peroxodisulfuric acid. Peroxodisulfuric acid also we can say. What is the structure? Sulfur. Here is sulfur. Then double bond O, then 2 oxygen, that is 2 hydrogen will be like this. Then remaining 2 oxygen will be like this. This is called peroxodisulfuric acid. So this is called peroxide. This is the peroxide linkage. So 2 sulfur 2x plus how many hydrogen? 2, that is 2, plus how many oxygen in oxide state? 1, 2, 3, 4, 5, 6, that is minus 12. Again I am repeating, how many oxygen? 1, 2, 3, 4, 5, 6, that is minus 12. And 2 oxygen each carry minus 1 because in peroxide state that is minus 2. So minus 2 is equal to 0. Now what is the value? Now 2x cancel is equal to 12 plus 12, x is equal to plus 6. So in this way also you can calculate. This is one important thing, you have to draw the structure. Then you can know what is the actual oxidation number. Without structure if you do, your answer will be wrong. Then suppose chromium pentoxide. If you calculate chromium will be how much? Plus 10. It is wrong. But if you draw the structure, chromium oxide is like this. You see, this is the actual structure of CrO5, chromium pentoxide. Here, this indicates these two. This one is a peroxide part, this is also a peroxide part, this is oxide. So, chromium is X plus, here oxide is minus 2, then 2 peroxide. Here total peroxide oxygen is 1, 2, 3, 4, and each oxygen carry minus 1, that is minus 4 is equal to 0. That means x is plus 6. Without this thing, if you calculate, x will be plus 10. It is wrong. Cannot be, chromium oxygen number cannot be 10. It is not possible. Maximum oxygen state is plus 8. Remember. So it cannot be more than, it cannot cross 8. That's why it is wrong. If you calculate roughly, that is using that traditional method, that x minus 2 into 5, that is x is equal to plus 10. So it is wrong. So structure is very important to calculate this oxidation number. Another method I will give another example. I will give you that for example hydrogen cyanide. This is the structure of hydrogen cyanide. So hydrogen cyanide, I can calculate the oxidation number of carbon. Here hydrogen is plus 1 and carbon is x. And here nitrogen is, as nitrogen is more electronegative than carbon and it is bonded 3 bonds, attached 3 covalent bonds, it will be minus 3. As more electronegativity carry minus charge. So minus 3 plus 1x, value of x is plus 2. Similarly, hydrogen isocyanide, same, if you draw without structure you cannot calculate. Structure is very important. That's why its structure will be, hydrogen will be plus 1 and N will be here same, as it is more electronegative than carbon. That's why it is minus 3 and carbon is x, implies x is also plus 2. So in this way you can calculate oxidation number of different elements in the, for example, if it is multiple carbon is there, so you can do like this. Suppose acetic acid, structure of acetic acid is like this. what is the individual oxidation number of each carbon? We'll discuss now. So different carbon, this is first carbon, this is second, this is your first carbon C1, this is C2. If you give the number, then if you calculate the oxidation number of this carbon, here 3 hydrogen, remaining carbon will be how much? -3. This is your -3, and this carbon, which one? Second carbon. If you see the second carbon, hydroxide is carry -1, oxygen carry -2, so it will become +3. So this carbon, first carbon is -3, second carbon is +3. If you see, so that result, this is all carry, this is +1, this is +1, this is also +1, this carry -2, and the whole hydroxide carry -1. Okay, in this also you can calculate the oxidation number of the total is 0. Just if you see, whole oxidation number is 0. +3 and -3 0, and here -2 and -1, that is -3 and +3 0. So this is the oxidation number of these two carbon. Although it has 2 carbon, but both carbon has no same oxidation number. So oxidation number calculation depends upon the environment. That means it attached to the elements, its nature depends. So as per the nature of the bonded atoms, the oxidation number calculation also varies. So in this way you can calculate the oxidation number if practice more. Then next part we will discuss what is oxidizing agent and what is reducing agent. Okay, so you finish this one, then I will remove. Okay, next we will discuss now what do you mean by oxidizing agent. Oxidizing and reducing agent. Oxidizing and reducing agent. The definition is like this. Oxidizing agent means which oxidizes other but itself is reduced. Itself is, this thing you remember, this is very important thing. Itself is reduced. The substance which is reduced is called oxidizing agent. Then a reducing agent is which reduces other but itself is oxidized. Itself will be oxidized. That is called what? Oxidizing agent and reducing agent. You have to remember this thing. Oxidizing agent means itself is reduced, means reduction takes place on it. And reducing agent means itself is oxidized, that means oxidation takes place. So in this way you can just define what is oxidizing agent. For example, copper oxide plus ammonia on heating produce copper, nitrogen and water. Just you see which is undergo oxidation, which is undergo reductions. Here what you see the change. As here it is loss of oxygen, so it is a reduction. That is reduction. This is reduction. Copper oxide is reduced because loss of oxygen. Loss of oxygen is called reduction, so it is reduced. As it is reduced, so it is a oxidizing agent. But here ammonia, if you see ammonia to nitrogen, what happens? Here ammonia having hydrogen, nitrogen having no hydrogen, loss of hydrogen. Loss of hydrogen means oxidation. So it is oxidation. Oxidation means it is oxidized. So as it is oxidized, so it is a reducing agent. So ammonia is a reducing agent and copper oxide is oxidizing agent. For example, zinc oxide plus carbon changes to carbon monoxide plus zinc. Here zinc oxide to zinc is, that is reduction, loss of oxygen. So it is a reduction. Loss of oxygen means it is reduced. As it is reduced, so it is oxidizing agent. But carbon changes to carbon monoxide, so it is oxidized. As it is oxidized, so it is reducing agent. Just opposite. So remember the tricks that oxidizing agent means it will be reduced. Reducing agent means it will be oxidized. So these two things very important to remember. Oxidizing agent means it should be reduced, and reducing agent means it will be oxidized. In this way, we can know which reagent is oxidizing agent, which reagent is reducing agent. Another thing remember, for oxidizing agent, as it is reduced, so oxidation number, oxidizing agent means itself will be reduced. As reduced, oxidation number decreases. Reducing agent, as itself is oxidized, so oxidation number increases. That is also important. What? For oxidizing agent, oxidation number decreases, and for reducing agent means it will be oxidized. Oxidized means oxidation number will be increased, and oxidizing agent means it will be reduced. Reduced means oxidation number will be decreased. So this is some specific difference between oxidizing agent and reducing agent. So today we discuss the calculation of oxidation number, then identify oxidizing reducing agent, and definition of oxidation reduction, and types of redox reaction. Okay, thank you all.